Hello, hello. In this lesson, we are going to be comparing fractions, and I have selected 4 different ways for us to try, so let's get going with those right now. All right, so we're going to be comparing fractions, meaning we're going to be making statements about them. Are they equal to each other? Is one larger than the other? Is one smaller than the other? We just need to be able to read fractions and see which one is larger. That is the skill that we're trying to develop in this lesson. So our first question looks at granola bars, okay? So we have a young lady by the name of Adriana, and then we also have June. So both of them have granola bars, so they have the same substance. There's no different there, same brand, same flavor, same shape, all of that, except they have cut their pieces into different sizes. Adriana has cut her pieces into 2/4. June has cut her pieces into 5ths. So June has 5 pieces total, and Adriana has 4 pieces total. Now Adriana eats 2 of hers, and June also eats 2 of hers. So now what we are trying to ask ourselves or understand is which girl ate more. Because on the surface level, it seems like, oh, they both ate 2 pieces, they both have a granola bar, you just told me it's exactly the same size, etc. So it was the same size to start with, but their pieces are smaller. So kind of like Costco pizza, if you've ever had Costco pizza. Their pieces are really quite large, and if you're having a birthday party or maybe more people come over than you expected, you can cut those pieces in half and then you'll have more pizza. You didn't somehow magically get more pizza. You didn't run to Costco and get more pizza, but you changed the shape of your size. So that is the same exact thing that's going on here. They changed the size of their pieces, okay? So who eats more, Adriana or June? Well, Adriana eats more, and the reason that she eats more, despite the fact that both girls eat 2 pieces, is, one of the ways to look at it, is by comparing it to the halfway mark. Okay, so we can draw it out if that helps you, and you can also do a number line if that helps you. I did both just so that you could take a gander at both. So Adriana eats more, and the reason for that, the reason that I know this, is because on a number line, which is a second way that I chose to show it, I'm dealing with 4ths for Adriana, and I'm dealing with 5ths for June. So Adriana has half of her pieces, because if I think of what is half of 4, that's how you find the halfway point of a fraction. You find what is half of the denominator, and what's half of the denominator is 2. So Adriana essentially eats half of her granola bar, whereas June, on the other hand, half of 5 is 2.5. So she eats a little less than half. Now their pieces aren't drastically different, but they are different, and one is bigger and one is smaller, and so this is important to know. Another way, as opposed to looking at only the half, is which one is closest to the whole. Now when we think of fractions, we think that any numerator over the denominator that's the same number, so 2/2, 4/4, that equals 1, so that's the whole. So the whole of June's would be 5/5. The whole of Adriana's would be 4/4. So who's closest? Well, Adriana is only 2 pieces away from her whole, because 4 minus 2 is 2. Whereas June is 3 pieces from her whole, because 5 minus 2 is 3. So who has more pieces left over? June does, and so therefore she has less, because fractions is one of those kind of like opposite day where the more pieces you have left, the more pieces you have, the smaller your pieces are. So it's odd because, you know, the more dollars you have, the more money you have, but in fractions, the more pieces you have, the smaller those pieces are. So I introduced a few ways here, and we're just going to perfect them a little bit on these other problems. So I introduced the half comparison to draw it out, to do a number line, and to look at the whole. Okay, so let's try another one here. This one is going to look at equivalent fractions. So number 2 is asking which is larger, 2/100ths or 8/10ths? Well, this one, as opposed to drawing it out and doing a number line, y'all, I don't want to draw 100 boxes. So I am going to use an equivalent fraction. I'm going to work smarter, not harder. Because I don't have the same denominator here, I need to do something to make it the same denominator. I could have done that up here as well. It wouldn't be wrong if you did. You would have to go out farther. You'd have to go to something that both 4 and 5 can go into, and the closest number that is 20. So down here, rather than having to do like actual math, I already just, by looking with my eye, can see a cheat. I notice something between 100 and 10. What I notice is that 10 is 1 0 away from being 100, which means that 100 is 10 times 10. So, knowing that information, I can make 8/10ths into an equivalent fraction, and it does not change my answer because the word equivalent means equal, so it's making my answer equal. It just shows it in a way that I would have the same denominator, and then that way I can, compare them with a little less difficulty than trying to do it this way. So an equivalent fraction, however, does have a rule. Its rule is what you do to the numerator, the top, you must do to the denominator, the bottom. So what you do to one, you must do to the other. So if you change the denominator, you must change the numerator, vice versa, right? So I want 100 on the bottom. And as I've already said, I know that I do that by multiplying 10 times 10. However, in order to make it an equivalent fraction, I must do the same math to the numerator. So now I have 8 times 10 over 10 times 10, which is 80 over 100. Now I can take a look at these two numbers, no problem, right? I know, now I'm comparing 200ths and 80/100ths. Well, come on now. I know that 80 is significantly larger than 2, right? So I know that 2/100ths is smaller than 80/100ths. But because 80/100ths is the same exact number as 8/10ths, that must mean that 2/100ths is smaller than 8/10ths. Okay? Third way. So the third way, we are going to just look at the halfway point. We're going to give that another gander. So, which is larger, 2/3 or 1/6? Right here, right now, I could do something. I could do an equivalent fraction, the same, because I notice a relationship between 3 and 6. I know that there are 2 3s in 1/6, which means that 3 times 2 is 6, right? And so I could do 2 times 2, 3 times 3, or 3 times 2, excuse me, which would be 4/6 and 1/6. You could do an equivalent that way, but for the sake of this problem, I want to show you a new way. I want to show you the halfway. So I drew it out again. I have 2/3 and I have 1/6. Now just looking at this looks like 1/6 is bigger. It has more pieces. True, but we're only looking at one of those pieces. So would you rather have 2 of the larger pieces or 1 of the smaller pieces? That's essentially what you're asking yourself. So 2/3. Well, 2/3 is larger than the halfway point. And I know this because I ask myself, what is half of 3? Well, 1 1/2 is half of 3. 2 is larger than 1 1/2, so therefore 2/3 is larger than 1/2. If I go to a 1/6, the halfway point in a 1/6, I ask myself, what is half of 6? What's half of the denominator? It is 3. And then I look at my current numerator. My current numerator is 1. Well, 1 is less than 3, so that must mean that 1/6 is less than 1/2. 2/3 is more than 1/2. 1/6 is less than 1/2. Therefore, 2/3 is larger than 1/6. Last one. So now we're going to ask ourselves which is smaller. And we're going to use the closer to the whole method for this one, okay? And we also did some equivalency here too. So I have 3/12 or 1/3. I see a relationship between these denominators if I want to get like denominators. I know that I can do an equal math to 1/3 and get that to be a 12th. I know that 3 times 4 is 12, but what I do to the bottom, I must do to the top. So I say 1/3 times 4/4, because I wanted 3 times 4 is 12, but what I do to the bottom, I must do to the top. So because I multiplied my denominator by 4, I must multiply my numerator by 4. So now 1/3 becomes 4/12. Those are the same exact number. No magic happened there. A little bit of math magic from our good old noggin, but no magic happened that like changed the number to whatever I wanted it to be. It's just math. 1/3 is the same as 4/12. Now, knowing that information, I know, because I'm dealing with 3/12 and now 4/12 because I did equivalency, I know that 4 is larger than 3. So if I'm asking myself which is smaller, well, 3/12 is smaller because 1, it is farther from the whole, it is farther from the half. 4 is a little closer, not by much, but it is still closer. So 3 is smaller than 4. So 3/12 is the smaller fractions of 4/12. All right, I'm going to give you some practice problems. Ask me questions if you got them. You got this. Thank you.